This video is for people who have a lab report kind of like this. It's a heavy metals lab analysis report from CWC Labs. And in this video, my name is Mike Adams. I'm the founder and director of the lab. I'll explain how to interpret these results so you can understand the composition of the product or sample that you had tested. So first thing to realize is that this is a test of the elements of a substance. Whatever you sent us, whether it's your hair or a vitamin or a piece of food or a soil sample, this test, which is done via ICP-MS, which is a kind of mass spec instrument, it blasts apart all of the complex molecules, blasting everything into its constituent elements. You know, elements like carbon and oxygen and nitrogen and aluminum and so on, those elements are combined to make complex molecules. We're not testing those molecules. We're blasting them apart and testing just the elements. So that's why this is called a metals analysis, or really it's an elemental analysis of the composition of your sample. Now the results here are given in parts per billion concentrations. So I want you to bring up your sheet that looks something like this, and you should have a table, and I want to go over the columns in that table. So first of all, you have the element. And you'll notice that magnesium is the first element, that's Mg. And below that is Al, which is aluminum. And below that is K, which is potassium, and so on. These are the elements. You can look these up. I mean, they're well known. They're commonly, you can go to webelements.com if you're curious what symbols are for which elements. But the ones that you should be most interested in, if you're concerned about toxicity, would be lead, which is Pb, arsenic, which is As, cadmium, which is Cd, and mercury, which is Hg. Now, nutritive elements are good elements, and those would include magnesium and Mg, maybe trace amounts of zinc, Zn, as well as copper, Cu. Copper can be toxic if it's too high, but in very low doses it can be nutritive. Now, aluminum might be interesting to you. Many people are curious about how much aluminum they're taking in, so that's Al. And in addition to that, we have silver, which is Ag, Cs, which is cesium. This is the non-radioactive isotope usually. And then we have uranium, which is usually the non-radioactive form, mass of 238. So let's go to that next column, which is mass. So you with me so far? The first column is the element name. Second column is the mass. Now, elements have a certain atomic mass. And these masses that you're looking at here show the mass of the element that we're looking at. Now, because some elements have multiple isotopes, they have multiple masses. For example, if you go look at lead, which is Pb, you look down the chart, you'll see lead is at 206, 207, and 208. That's not a mistake. We're testing the three different types of lead, you might say, or three different isotopes of lead, and giving you a concentration of each of those. The same thing is true with, I believe we're doing two isotopes of cadmium, 111 and 114. And also mercury. It's good to get multiple isotopes of mercury, 200, 201, and 202. Now, other elements, such as aluminum, are called monoisotopic, which means they only have one mass, such as 27 in that case. So if you go look at aluminum, you're going to see it's 27. There isn't a 26 aluminum or a 28 aluminum, it's just 27. All right, the next number is a concentration, the next column, concentration. This tells you the concentration in terms of parts per billion of that element that was found in your sample. And as you can see, the next column over is the units, which is ppb. Now, ppb means parts per billion. Now, a part per billion, this is crucial to understand. If you have a number, a result, a concentration here that says, let's say, 10,000 parts per billion, that is equivalent to 10 parts per million, because of course there are 1,000 parts per billion in 1 part per million. Does that make sense? So 10,000 parts per billion is the same as 10 ppm, or parts per million. Now these are not given in concentrations such as micrograms per milliliter or nanograms per gram or things like that. Because in the world of inorganic chemistry, which is what this resides in with this elemental analysis, we tend to look at things in parts per billion concentration. This is a standard way to look at these results using ICP-MS mass spec instrumentation in a modern laboratory. So that's why they're ppb. And then, now you may wonder, what's good, what's bad? How much is too high or too low? For that, I advise you to go to a website called lowheavymetalsverified.org. Now, that's a website that I created to give you a rating system. I'm going to go there now. And if you're looking at different levels of verification for food and supplements, then as you can see from lowheavymetalsverified.org, verified A plus has a certain level that's allowed, and then verified A++ is better, and A++ is even better. But then we have levels described for verified B or C or D or F. So the concentrations are laid out here in ppm. So simply take that and multiply by 1,000, or move the decimal point 3 places to the right to get ppb. So for example, let's go to verified A, which shows you that lead has to be less than 0.25 ppm. Well, how many ppb is 0.25 ppm? The answer is 250. You simply move the decimal point over 3 places to get ppb. So 250 parts per billion of lead or less would be considered A status, or A verified. So go to your chart and look at lead, Pb, and you can pick any one of the isotopes, 206, 207, or 208. You don't add them together. You just pick one. Or you could average the results and take the average. If that number is less than 250 parts per billion, then you are at level A or better. If it's less than 120 parts per billion, you're at A+. If it's less than 50 parts per billion, you're at A++. And if it's less than 25 parts per billion, you're at A++. Now, the different levels, there are different levels for different elements. So for example, if you're looking at cadmium, verified level A, we allow up to 1,000 parts per billion, or 1 ppm. Why is that? Well, cadmium is a lot less toxic than lead. So there's a higher allowable level of cadmium in products versus lead, because we want this to be sensitive to the toxicity of these elements. It's also why mercury, you have to have less than 50 ppb, or what's called 0.05 ppm, in order to achieve verified A. Why is that? Because mercury is highly, highly toxic. Mercury is the most toxic element on this list. So that's how you can determine whether the sample you sent in has a good level or a bad level of heavy metals. Now, the next column is RSD percentage. RSD means relative standard deviations. For the most part, you can ignore this column. But you should know that the smaller the number, the more accurate the concentration reporting result is, because it means we had more data in which to gather the concentration numbers. The instrument, for example, is plotting data points using a very sophisticated mass to charge ratio detector. This is how mass spec instruments work. And as it's gathering these data, it is putting together an RSD calculation based on the sample size. So RSDs simply mean in essence, it's the reliability of the concentration that's being reported. Understand that these concentrations are not always exact to 1 ppb. They are, to be accurate, they have to be expressed in terms of a number plus or minus another number. One standard deviation of variance, for example, away from the number that's being reported. In a general sense, you can easily assume that this number is accurate to within plus or minus 20%. In most cases in our laboratory, they're accurate to within plus or minus about 6%, sometimes even better. Most labs consider plus or minus 20% to be very, very accurate. And in terms of accreditation, believe it or not, the accrediting agencies normally don't require you to be any better than plus or minus 20 or 30 or sometimes even 40%, depending on what you're looking for. It varies with pesticides. It varies with different chemicals that you're trying to look for. But for ICP-MS, plus or minus 20% is considered very, very accurate, very acceptable by government standards, FDA, USDA, and so on. And now, finally, the last column has to do with the detection mode. The detection mode shows you either analog or pulse, which means digital. So this isn't really of your concern. It's just added there in case you're curious. But some elements, if they're very high concentrations, they will tend to be measured or detected using analog sensor modes in the instrument. Other elements, if they're at very trace levels or low levels, they'll tend to be detected in a digital or pulse mode of the detector in the instrument. So you'll notice that the higher the numbers in this chart, they tend to be analog, and the lower numbers tend to be pulse. So that's all that means. It's not really any concern of yours. And finally, the lower table on this, which is the ISTD table here. The ISTD table means internal standards, and it's just telling you what it's seeing or reporting in terms of looking at internal standards and the internal standard recovery percentage. Now, in an ideal world, well, internal standards are tracing elements, you might say, that are added to the mixture, and they're put in there in order to make sure that the instrument is seeing things correctly. And if everything is 100% perfect, you would have exactly 100% recovery of every internal standard. You don't, because science, is never perfect in the real world. You're looking at recovery percentages. Sometimes they might be 85% or 96% or even 105%. Usually if they're plus or minus 20%, for example, within 80% to 120%, they're considered very good and very reliable. If you start to see those numbers get way out of those ranges, then that might be an issue. But we watch those numbers as well, and this is also for us to look at because we review your report before we send it back to you to make sure that the internal standards appear to be working correctly. So the bottom line is you are getting a readout here of both the trace elements, nutritive elements, as well as toxic elements such as lead and mercury that might be present in your sample, whatever you sent in. Now, is the numbers that you're seeing, are they safe? Well, we obviously can't make that determination because it depends on many, many factors, including what the sample is. Is it something you're eating? Are you sending us a sample of the paint on your house? Well, probably going to be high lead if it's an old house, right? Is it safe? Well, it's safe if you don't eat it, you know what I mean? Or if you don't inhale it. But it's not safe if you interact with it. If you absorb these toxic elements, it's not safe. A lot of people send us samples because it's a vitamin or supplement that they take routinely, and they want to make sure they're not getting a daily ingestion of toxic lead or mercury. And so this report helps them make sure that they're not getting that daily exposure. It shows them that their product is clean. Other people are sending us well water, for example, which is something that you might consume every day in your house. So it is very important to see what's in your well water. How much aluminum are you taking in? How much magnesium are you ingesting through your water, for example, or arsenic, which is very common in well water. So that's what this is for, to help you gain an understanding, some insight into the composition of the sample that you sent us, whether it's water, food, dog food, personal care products, cosmetics, makeup, or anything else like that. You could tell a lot, by the way, even though we don't test blood, you could tell a lot by looking at your blood. But you'd probably want to go to a clinician for that because there's a lot of special safety procedures handling blood, and we don't handle blood, so please don't send us blood. Thank you. But nevertheless, this can give you a lot of insight into what you're seeing. Now, this is especially true if you send us a hair sample. I think heavy metals analysis of hair is one of the best ways to determine your systemic exposure to toxic elements. It's obvious. Your hair is it's grown from the nutrients that are circulating in your blood, right? Your hair follicles manufacture hair, and they do that not by magic or voodoo, but they do that by using the constituents that are in your blood. So if you test your hair and you find that your hair has very high levels of mercury, it can only come from two sources. It's either environmental exposure or it's in your blood and it's ending up in your hair. So environmental exposure could mean you're getting mercury in the air, you're getting mercury in your shampoo perhaps, or you're getting hair treatments that would contain mercury. But what you can do is you could send us, for example, armpit hair. Armpit hair is usually not exposed to the elements, doesn't have the same air pollution. You're not getting a shampoo treatment of your armpit hair usually, but you can send us your armpit hair and get that analysis. You can compare it to the hair on your head, let's say, and you can see the difference between what is environmental pollution versus what we would call incurred toxic element composition coming from your blood and ending up in your hair. And by the way, I've tested my hair too, and there's mercury in it. I can't even as clean a lifestyle as I lead, and even having access to all this scientific instrumentation, I can't get the mercury out of my hair either. It's because so much of our world is so polluted. You get mercury when you eat shrimp at a restaurant, you eat tuna fish, you eat seafood, seaweed, you eat any of these things, you're going to get mercury. There's mercury in the air. It comes out of the coal-fired power plants. There's mercury in the aftermath of forest fires. They release mercury. And then, of course, people have mercury in their fillings. People get mercury in flu shots. People get mercury from, 1,000 different environmental sources. So it's hard to eliminate mercury. But through this process, through these lab results, you can at least start to narrow down perhaps what your exposure vectors might be, and you could eliminate those exposure vectors. And in doing so, you could clean up your body. You could get the lead out, get the mercury out, get the cadmium out, and so on. A lot of people are getting cadmium from coffee and cacao products, and there's lead in certain, rice products, and there's arsenic in rice, and there's arsenic in well water, and so on. So by doing this, you'll get a pretty good sense of the composition of whatever you sent us. And I hope that makes good sense. I really appreciate your support for our laboratory and your interest in this very important area of science. We are here to provide this public service so that you can live a cleaner lifestyle and have less lead, less mercury, and perhaps more magnesium and more zinc and things that are good for you. You should test your water supply. You should test the water that comes out of the tap in your kitchen, whatever you're using to drink or to shower in. You should absolutely test your hair to see what's your level of exposure. You might ask, well, how much mercury is high in hair? Well, I can't give you that answer, but I can tell you I've seen people with easily, 250 parts per billion mercury in their hair, and occasionally I've seen people with over 1,000 parts per billion or 1 ppm mercury in their hair. To me, that would be freakishly high. If you see mercury in your hair, even over 500 parts per billion, that's cause for concern. From my professional opinion, you should seek out a naturopath or a detox expert or someone who is an expert in the clinical side of diagnosing and treating heavy metals poisoning so that they can help you with, there are various things that you can do, such as chelation, but of course, limiting your exposure to these metals is the most important long-term strategy. You got to narrow down where the mercury is coming from, or where the lead or cadmium or arsenic are coming from, and then eliminate those things from your diet, eliminate them from your home, eliminate them from your environment. That's the only way to detox long-term. Remember that your body is constantly detoxing moment to moment. Every time you breathe, every time you sweat, every time you urinate or have a bowel movement, you are in effect removing toxic elements and toxic molecules from your body by drinking water, by having a clean diet, by eliminating GMOs and pesticides and other toxins and herbicides from your body, and toxic cosmetic products, which are very common, toxic personal care products, laundry detergent, dryer sheets, fabric softener. All these toxic things, you eliminate them from your life, and your body naturally detoxes itself and gets cleaner by the day. So getting clean water and clean food and organic food and superfood into your system is actually the most important thing that you can do long term. In addition to identifying any kind of major vector of exposure. It might be a workplace, for example. If you're a welder and you have very high cadmium levels in your hair, you shouldn't be surprised. Welding rods contain cadmium and toxic elements, and you're breathing that stuff. You're inhaling cadmium, and it goes right into your hair. So, a lot of things start to make sense when you look at the numbers, and that's what this is all about. In any case, hope you found this valuable. My name's Mike Adams. I'm the Lab Science Director of CWC Labs. I appreciate your support, and I hope you found this interesting as well as valuable in helping you live a cleaner, healthier life. Thanks for watching.